When most people look at something like this, they automatically assume that that's a transformer because that's basically what a transformer looks like. Some people might look at it and go, hey, that's just like a magnetic amplifier. Well, they both look the same, but the differences are their operating principles. They both work on magnetic field lines. A magnetic amplifier is used to control the primary line, and of course, transformer is just made to change voltage and current for a primary line. So the thing about this is it opens a doorway into magnetics that a lot of people probably haven't really looked at. So this is hooked up to a fan, just a little, and it's running through it. And so what you'd have if you hear the fan go down, you hear that start humming, because the magnetics screws up the primary line. So that's the basis of how a magnetic amplifier works, except they add a secondary current to the secondary coil and control the magnetic field on the secondary. But if you simply short the secondary, now the magnetic fields become perfectly balanced and there's no disruption on the primary anymore. It's 100% about magnetic fields and their field lines. A lot of people think that, well, the core gets saturated and that's what causes that to happen, because they say once it's saturated it's kind of like air. But really there's no magnetic field in there. It's like it's gone. But actually it's not gone. It just doesn't interact with the iron anymore. These are just metal shavings. And when you set them on there, nothing happens. You can see those shavings, they don't do anything. They don't do anything at all. They're just sitting there. So I've got a little magnet right here. You can see it's just a little button magnet. If you set the button magnet, if I can get a hold of it, in a little tray and look, you can see the magnetic fields are still there. They just don't interact with the iron core. So the next step is we'll use the magnetic fields that are developed by the system itself, and I've added some jumpers, and I've simply hooked up a resistor over here. If we let the system develop its own magnetic fields, and we have it shorted right now so that basically there's a short across the secondaries, excuse me, then it acts like nothing's there, just like it did a minute ago. But we can change this by adding resistance to that secondary coil. You see, I've added resistance. You can hear it start to buzz. You can hear the fan go down, and you can see it's grabbed a hold of that. So all I've done is add a resistance to the secondary coil. In understanding that you can do that, it opens up a doorway to some areas that, well, hadn't been possible, but you have to overlook certain laws and kind of put them in the back of your mind for a little bit. So if I take the resistance back out of this, you can hear the fan speed back up, the vibration starts to go away, and so does the magnetic field. So understanding the magnetic fields and the field lines, and the fact that the secondary generates its own magnetic field. It's on the basis of diamagnetism. It's simply an inductor coil that's made out of copper that's being subjected to a magnetic field, and it makes a magnetic field of the same intensity as the primary magnetic field. So I'll show you something here, so give me just a second. Short that across. Okay, so I just got a little meter hooked to it. Turn the fan back on, just short it across. If we go to our amps, we got 2 amp draw on this motor. And across the secondary coil, we've got 1.99 by this meter. If you look at the meter behind it, it also says 1.992. So the secondary field in the coil is an exact replica of the field on the primary coil. So we can use that, then as we know that we can control that motor speed, we can control the primary line, we can use that. Well, not only is it making the current, but when you add resistance, it also makes voltage. It's just backwards. It starts out with a predetermined current, and as you add resistance, you start to develop voltage that goes with it. And so this ties into something that I've developed, which I just simply call an energy harvester, which harvests power factor correction. And so that's what this will lead into, and I'll show you that.